Hey everybody, I hope you watched the homework 11 video. Let's do homework 17 now. Here's 17. Okay, so in this homework we're going to be talking about perpendicular bisectors and other perpendicular lines. So looking at number 1, it says segment MN is given. We see it here. And it says complete the following statement. RM is congruent to Rn. So that means point R must be on the, and the answer is perpendicular bisector. Excuse me. Of Mn because it is equidistant from the endpoints. So again, just to show you that, I think that fact is kind of obvious from our construction method. If you were to center on N and open the compass up to point R, just like this, right? Then think about the way we do our construction. We swing an arc. Then when we go to the other endpoint, because R is equidistant from M and N, you'll find that your arc goes through point R again. And so the way that we construct our perpendicular bisector is we find one point that's equidistant, and then we find another point that's equidistant, and then we know that we can connect the dots, and that the line that we get will be our perpendicular bisector. So with our ruler, we line everything up, and then we can draw a line. And we know that blue line is the perpendicular bisector of Mn. We know that every point on the perpendicular bisector is equidistant from the end, the end points. Let's take a look at 2. Number 2 is this one about the railway station. And so it says a railway station is to be constructed by the track equidistant from town A and town B. So use construction to determine the exact location of the station. So if I'm trying to be equidistant from town A and town B, then I need to do the perpendicular bisector of the line segment that connects town A to town B. Now you don't have to draw the segment, but you can if you want. So here it is. We want to draw a line that's the perpendicular bisector of that segment. That means you center on point A. You make sure your compass is opened up more than halfway. So right here is fine. And then we can start swinging arcs, and I usually just make a semicircle centered at one point. Then I go to the other endpoint and I swing a second semicircle. And that's always going to give me 2 points of intersection. We see one here, and we see another one here. And now you can just take your ruler and line it up with one of those points of intersection, and then turn it until it lines up with the second point of intersection too. And then once you've got it set up just so, you can use your pencil to draw a nice line. So I'll draw a line from here straight through, and that red line I just drew is our perpendicular bisector. So the point that represents our railroad station has got to be the point that's like right next to the railroad. So I guess it could be here-ish, but I'm going to put it on the far side of the railway. Put it here. And I guess it didn't tell us to mark it as anything, but I'll mark it as R. That point there is the point we're looking for. Hopefully that makes sense. Now, is it really equidistant from the two towns? Well, let's find out. Using our ruler, you can measure the distance to town A. Seems like it's about 54, 55 units. And as I turn my ruler to measure the distance to town B, it's about 54 units again. It doesn't look quite the same, but I think that's because I'm not, my ruler wasn't perfectly lined up on it. So I feel good about that being the right point. So let's do number 3. Number 3 says use the given segments with length A and B. Construct a right triangle called ABC below with a right angle at B, one leg of length A and another leg of length B. It says hint, start by constructing a perpendicular to XY passing through B. So this is one of those constructions we learned. To make a perpendicular line through a point that's on a line, you're going to center on the point that you want to pass through, which for us is B. And then you can open your compass to really any setting you want to. The idea is you want to swing an arc to the right and an arc to the left, because what we're trying to do is form a line segment that B is right in the middle of. So by swinging these two arcs, I now know that if I put points here at these points of intersection, then B is right in the middle of the line segment whose endpoints are these green dots. So that means now I can basically just do the perpendicular bisector construction on that line segment, the one formed by the two green dots. So you see me opening more than halfway. And I'll just swing an arc down. I could swing up, I could do my whole semicircle again, but I don't need 2 points of intersection this time. I only need 1, because I already have point B as well. So just 1 point is good enough this time, because I can line up my ruler with point B. So I'll center on point B, open my ruler so it's just right, and then I can draw the line. So this line is now perpendicular, and it's located at B, and then we want one leg to have a length of A, so we better set our compass to A like we did before. I'm a little long, so shrink that down a smidge. And then we can center on B and swing an arc down. And then we know that length is A. Now we want another side of the triangle to have a length of B, so we'll set our compass to that length. And then we can center on point B, and this time I'll swing along the other side of the angle. So I'll swing over to here, and I know that's giving me a length of B. So this triangle is supposed to be called ABC. This point's already called B, so I guess this point here could be A. This point over here could be C. And then in red we can highlight our final answer. We can choose that size, choose this color red. We're going to go from B down to A up to C, C back to B, and there's my perfect right triangle. You can see the right angle is at B. So there's your right triangle. And again, we said this side here was of length A. This side up here was length B. So there you go. That's how we would do that construction. Number 4 is talking about a laser beam, spelled weirdly for some reason, but it's perpendicular to line M and it extends infinitely from point A toward these triangles. So use constructions to draw the laser beam and determine how many triangles it will intersect. And then it says shade those triangles. So more importantly is, how do I even do the perpendicular? Well, for this we said you'll center on the point that you want to pass through, and you'll just want to make sure that your compass is open wide enough that your arc will intersect this line. So I basically just open a little bit past the line. Then I know that when I swing the arc, I'll get a point of intersection up there. I'll get another one as I swing around like this. And again, our goal was just to slice off these points of intersection. And what we've done, again, is created a line segment between those two green dots whose perpendicular bisector is guaranteed to go through point A. So again, we're back to just doing the perpendicular bisector construction, which is the one where we center on this endpoint, and we just make sure that we're open more than halfway. So right now, I'm already fine, but I just got to make sure I'm more than halfway. Maybe I'll go here. I'll change my compass to the color orange, and I'll swing an arc out to the other side of A. And again, we only need one point of intersection because we already have point A. So point A plus another point will give me the 2 points I need to draw a nice clean line. So there's that. I'll grab my ruler. I'll line up the 0 mark with point A. I can twist my ruler now till it lines up with the point that I found. Then I can just draw a line. Let's make the line blue. So there it is. That thing's not perfect. I missed the dot by a little bit. I missed that by a little bit. You know what? Let's just grab it and move it. Hold on. Things connected to everything else. That looks a little better. So how many triangles do we hit? And let's shade them. I think I'm going to count that one as getting hit. That one's getting hit for sure. I'll count that one. That one's a little close. Let's just say no, it doesn't hit that one. Count that one, count that one. I don't know. You could make an argument that it hits these ones too, but I'm not going to count them. Who cares? So how many is that? 1, 2, 3, 4, 5. I'm counting 5. And I've shaded the 5 that I think it is. So that's how you do number 4. And let's see if there's a 5. Yeah. So it says construct the perpendicular to AC through B and label the point of intersection as P. And then it wants you to give the name for what segment BP is. So this problem is kind of similar to the last one. We do have basically just a line. There's the line that goes between points A and C. Yeah, let me use this tool. So you could extend this if you wanted to. I think maybe you probably should. So there's just a line. AC is like a line. And then there's point B. And you guys can see that point B is not on the line. So we are going to use the exact same construction from the laser beam problem that we just did. The one where we center on the point that we want our line to pass through. We open up just below the line so that when we swing an arc, it'll hit it twice. So I can swing to the left, swing to the right, and that's going to slice off 2 points of intersection for me. There's one right there, right here, and another one here. So now we basically just do the perpendicular bisector construction where we center on the end, open up more than 3/4 of the way, how about here? And since we already have point B above the line, let's swing a couple of arcs down here below the line. And they'll intersect each other, and then we'll be able to connect point B through that point of intersection. So if I connect them with a line, goes from B straight down. That's great. That's not necessarily what this question was getting at though. There's a little bit more. I'm going to slide that up a bit. I think what this question really wanted you to do was now label that this point of intersection here is P. And then of course we had the original point B. So there's a name given to this line segment, just this piece of our line, and it's called the altitude. And that's something you should know about triangles from now on, is that the line segment that you can draw from a vertex to the opposite side so that that line segment is perpendicular, that line segment is called an altitude. Okay? Is there more? No, that's it for that one. So that's the end of homework 17. I'll try to get that posted. You can watch. And then upcoming soon is going to be 19 and 21 as well. So check those out if you need to. I'll see you on Monday.